So the next chapter will be on hypothesis testing, and we start with numerical variables. And let's start with an example to motivate why we are interested in testing a hypothesis. So this is an example on gender discrimination. Let's assume you have 48 male bank supervisors. Yeah? And every of these 48 supervisors was given the same personal file of a person, and the supervisor had to judge whether this person should be promoted or not. These files were identical, the same characteristic of this imaginary employee. Except for the gender, which has been assigned randomly to the file. Yeah? So they read the same file, but with a randomly generated gender on the file. And 35 of these 48 supervisors voted for promotion. Okay? So I should mention that there were 24 male files and 24 female files. So 35 of these 48 supervisors voted for promotion. Okay? And now one question could be, are females unfairly discriminated against? Yeah? Here in this table, I summarized the experiment. Yeah, we had for a male candidate, we had 21 promotion suggestions and 3 non-promotions. For the female, 14 to 10. So the percentage of males that got promoted, imaginary males, okay, was 88%, and of females 58%. So now we could say that looks unfair. Okay, because it's the same person, it has the same qualifications on paper, but of course the supervisors were different. Could be that the supervisor that got a female file and voted for non-promotion would have been acted the same if he got a male file. Could be. Yeah, maybe for this supervisor the candidate looked not promising enough. So now what are possible ways to quantify the probability that there is some bias going on? And that's what hypothesis testing is about. We have a hypothesis and we have an alternative hypothesis, and we need to decide which of the two scenarios is more likely. And usually it's done the following, that you have what's called the null hypothesis, H naught, and that's the status quo. Usually that means nothing is going on, nothing to see. All is random. Okay? All features are random. Or in our example, promotion and gender are independent. Yeah? Any observed difference is just due to chance. And the alternative hypothesis would be something is going on. There is some artificial bias going on, acting. And the burden of proof is always on the side of the alternative hypothesis. Yeah? So the question can be rephrased: is the data telling us, or other, could this data happen by chance if there is no gender bias? That's basically the question we need to answer. Okay? Yes? Question? No, okay. And then we get two possible answers. One is yes, the data supports the claim this is just chance. Then we have to then we have to stick to the null hypothesis, or no, and then we have to go to the alternative hypothesis. Okay, so it's always starting with the null hypothesis, set an alternative hypothesis, and do some tests. And that's the important thing. All tests that we do always assume that the null hypothesis is true. Okay? And then we can do some theoretical model, simulation, or nothing. You will see in a minute how this works. Okay. What we do is we make a simulation. So, what do I do? Let's see. Okay. Experiment means here I'm doing some random experiment, and if the result of my random experiment looks the same like our data, we can say, okay, that's random. Yeah? And what I'm doing is the following. I know we had 35 promoted and 13 not promoted files. So I just create a list of 35 letters P for promoted and a list for 13 NPs for not promoted. So that's a list of strings, 48 strings, 35 promoted, 13 not promoted. And then I randomly assign 24 male indices and 24 female indices. So in other words, I take these 48 strings, and for every single one I randomly assign the gender such that at the end I have the same equal portions of female and male. Okay? And then I count how many male promoted and how many female promoted I got. What I do, and take the difference. Yeah? I take the difference between here. And that's the result. The mean value between, so the difference between male and female promoted, randomly promoted things, is about 0. And with some standard deviation that I get here. Now, that's the result of the numerical experiment. How do we interpret it, given this data? What would you say? Yeah.
We should try to check how likely, like in how many, what is the probability that we get a difference of this much, that male minus female is 7 or like -7 or lower.
Genau. What we get is a difference of 30%. So one way would be to look up in the numerical experiment how likely is a difference of 0.3. And you see, in our experiment of 100, not a single random experiment showed a difference of 0.3. Yeah? So we were not able, with 100 experiments, to reproduce the data. Okay? So based on this, we could say the data shows, the chance that our data is just randomly, the result of random scatter, is 0. If we had much more experiments, maybe we had some cases with even larger differences, then we could compute the area of the histograms with 0.3 or larger, and quantify this in terms of probability then. So far our area is 0. So this experiment tells us no, it's not random. Okay? Good.